And another welcome back. We're at part 3 of section 2.3. We've gone through almost an hour of video already. This is definitely multiple class periods that we're taking on this, but here is part 3, and we're finding zeros of a polynomial function, and this is total old school here. You won't have to do all of this at one time, but it's a good kind of representation of everything we're doing in this section. Use Descartes' rule of sign to determine the possible number of positive and negative zeros. So Descartes' rule of sign gives us the number of possible positive zeros. How many times does the sign change? I go negative to positive to negative to positive. So we change, change, change. There's either 3 or 1 0 to the right. Descartes' rule of sign, the number of possible negative zeros. Well, let's find what happens to the left. Negative survives cubing. Negative times negative, positive 3x to the third. Negative does not survive being squared, so that's plus 20x squared. Negative survives here, plus 36x, and the negative isn't a factor there. There are no sign changes, so there are no possible zeros to the left. Think about this for a moment. Well, I'll come back to that perhaps. I want to get on with this. So what this would tell me is that we only need to look to the right for zeros. Now, the rational zero test says that if we have a rational zero, it must be a factor of 3 over a factor of 16. So let's take it. Actually, that is incorrect. It's a factor of 16, over a factor of 3. That's the rational zero test. We put these over that. So my factors of 16 include plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Yikes. 3's plus or minus 1, plus or minus 3. So here's my possibilities. I've got possible rational zeros to the right of 1 on 1, 1 on 3's, plus or minus 1/3, 2 on 1, plus or minus 2, 2 on 3, plus or minus 2/3, 4 on 1, plus or minus 4, 4 on 3, plus or minus 4/3, 8 on 1, plus or minus 8, plus or minus 8/3, and 16, are you kidding me? Plus or minus 16 and plus or minus 16 on 3. Those are possible rational zeros. And guess what we had to do? And I know it's sloppy, but I'm trying to write fast through this. We had to start, we'd try 1 and we'd hope 1 would work, and 1's not going to work. And then we'd try negative 1, then we'd try 1/3, and we'd try negative 1/3, and we'd try 2, and we'd try negative 2, and we keep trying until hopefully one of them was a rational zero, and no guarantee there are. Well, what did we learn here that could be helpful? I don't have to look for negative zeros. That just cut, what did I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I had 20 possibilities. Now there's only 10 possibilities. And that would cut that number in half at least. I don't have to mess with trying to synthetically divide negatives through that. But here's what we're going to do. We're going to list those perhaps, but then we're going to just magically find the ones that works, or the ones that work. Let me get a little darker on here. So y equals, this is that big one we had in that last part. I'm going to enter this function, negative 3x to the third, plus 20x squared minus 36x plus 16. I'm just going to zoom standard this, zoom 6. Now, I'm not expecting any zeros to the left, and I'm not even guaranteed necessarily of zeros to the right, but it looks like we've got some there. Would I need to zoom out? Would I need to zoom out in order to figure out if there's a fourth one? Nope, because there's only 3 or 1 to the right. So if this is in my list, let me see so you can see our list at the same time. If this value is in my list right here, I expect that would be, it's got to be 2/3, wouldn't it? That's the only one that's just a little bit less than 1. So I'm going to go, just to see if this rational 0 works, I'm going to go trace, and I'm going to enter 2 divided by 3. And sure enough, that's a 0. So I'm going to put over here my zeros include 2/3. Looks like maybe 1. 1 is a 0. Looks like maybe 3. 3's in my list, isn't it? Is 3 in my list? 1, 2, 3. Oh no, 4. Looks like maybe 4. 4's in my list. And 4. Okay. So this is pretty cool now. I'm going to go through some synthetic process with these guys. I'm going to save 2/3 for last. And we're going to start dividing these out. So let's lock this guy in. So I'm going to take 3, I might need some more paper, write small. I'm going to go -3, 20, -36, 16, and I'm going to divide that by 1 because that's going to be the easiest one to handle first. All right, let's see where we go here. So that's -3 and 1, -3. 17 and 1, 17. Is that a 36? 36 and 16. 1, 17. That is not 16. What is the problem here? -3, 20, -36, 16. 1 should synthetically divide that. And I do not get this. I'm not going to give up on this yet because I've already put some time into this. We've got 1 over there. 1 was definite. Oh, 1's not a 0. That was 2. That was 2. Glad I caught it. Go back here. It wasn't 1. When I put in 1, I got -3. When I put in 2, I get a 0. Don't know if you could see that or not. But 1 is most definitely not a 0. Okay. My fault. -3. 2 times -3, that's -6. Now I get 14 times 2, 28. -36 and 28 is -8 times -2 is -16, and I got my 0. Now what I can do is I can just pick it up from there. I'm going to run 4 now through these. And I get -3, -12, 2, 8, 0. So there we've got them all. It shows if you run, understand this last term is -3x plus 2. And there's my positive 2/3. You could run 2/3 through this and you get 0, 0 again. So what all are we supposed to do here? List the possible rational zeros. Did it use Descartes' rule? Did it use a graphing calculator, graph F, so that some of the possible zeros in parts A and B can be disregarded? Determine the real zeros. So there they are. We had them. Now, let's say this had been to the 4th and there was another 0 out there. I could just continue that synthetic process until we divide it down to just this linear term. Okay, so here's how I'm going to have you handle these types of problems. We're just immediately going to go to our graphing calculator. And I'm going to enter my function here. Y equals, clear. We're going to go x to the 4th minus x cubed minus 29x squared minus x minus 30. Everything right there. I'm going to go zoom standard. And I'm going to just try to find zeros here. Well, I got a couple of them anyway. I got a couple of zeros, and it looks like one is -5, so I will go trace -5 and see. -5, as you can see, is a 0, and it looks like 1, 2, 3, 4, 5, 6. 6 over 1, that's a possibility. 6. So those are zeros, and those are just passing through zeros. So I've got zeros at negative 5, and I'm going off the charts for how we're handling this, but this is the way I would like you to handle this assignment. Find those zeros, synthetically divide them. I'm going to run 6 to the 4th, to the 3rd, to the 2nd. I lost my computer screen, bear with me. To the negative 1st, or excuse me, just negative 1 to the 1st, and we've got a minus 30 here. Okay, that should end up being 0 if I did that right. 1, negative 1, negative 29, negative 1, negative 30. 1 times 6 plus negative 1, negative 5 times 6, negative 30. Oh, that's positive 5, positive 30. 1 times 6 plus negative 1, 5, 30, 0. And now I'm going to run negative 5 through that result. And I get 1 and negative 5 and 0 and 0 and 1 and negative 5 and 0, which means after I synthetically divide, after I divide out this x plus 5 and x minus 6, I'm left with, this would be x squared, x and a constant. This is x squared plus 1 equals 0. So my zeros, of course, include negative 5 and positive 6. And when does x squared plus 1 equal 0? When x squared equals negative 1, and that can't happen in real numbers, so those are my only two zeros. So what will happen is you'll be able to get everything divided down to a quadratic with the aid of your calculator. And once we're down in a quadratic, we can quadratic formula, we can factor. If it ends up in this case, I can just directly solve for x by subtracting 1 and taking the plus or minus square root. So you'll be able to divide it down to a quadratic. In this case, there were only the two solutions. Of course, there could have been as many as 4. And that's what we're going to be doing here. Okay, upper bound, lower bound test. Now that one, I'm not going to go through why this works. There is a video about that on the website, and I will have gone through that in class probably by the time you're seeing this video, but possibly if you weren't here, or if you're just out there in the cyber world not attending my course, then there's another video for that. It's kind of, I think it's called Demystifying the Upper and Lower Bound. All right, so use synthetic division to verify the upper lower bounds. I will give a tiny bit of an explanation to this when I'm through. So upper bound, what that means is, it means that 1, 2, 3, 4. If 4 is an upper bound, that means any zeros are to the left of 4. And if negative 3 is a lower bound, that means all my zeros are to the right of negative 3. So there's no need to look everywhere else, which if you think back to this problem, might have been useful for us. It might have been useful, like if I tried 4 and I found out that 4 was an upper bound, I don't have to try 8 or 16. So how do we do that? We synthetically divide. I'm going to take 4, my upper bound, into 2, negative 3, negative 12, 8. Okay, I get 2, and I get 8, and I get 11, and I get 44, and I get negative 30, or I get positive 32, and I get 128, and I get 136. Now, what are we doing? We're hoping this ends up as a 0. If this ends up as a 0, then 4 would have been a 0. So what would happen if I put 5 in here? If I put in 5, this number will become bigger, making this bigger, making this bigger, 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 bigger. I'm never going to get back down to 0 by putting in numbers bigger than 4. The key is all of these, none of these were negative to keep us in check here. If the bottom row is all non-negative and you put in a positive number, then 4 is an upper bound. Okay? But had this been negative 32, now I got a negative and then back in play. They have to all be non-negative. All right, we're going to take negative 3 and we're going to run it through this. 2, negative 3, negative 12, 8. And I get 2 and negative 6 when I multiply, negative 9 and 27, 15, and negative 45, negative 37. So f of negative 3, take a look, f of negative 3 is down at negative 37, f of 4 is up at 136. Got a 0 between here somewhere, at least one, but I don't have any to the left. Think about this for a minute. If I put negative 4 in here, this would be bigger negative, making this be bigger negative. This would be, times negative 4 would be a bigger positive, making this a bigger positive. Times negative 3, negative 4 would make this an even bigger negative, bigger negative, making this an even bigger negative. Therefore, what they're saying here is if the signs go positive, negative, it's a lower bound. And let's say we got some, let's say we synthetically divided and we got something like this. Let's say I got 3, 0, 4, negative 1, 6. You can count that. You can count that 0 either positive or negative, whichever is your convenience. So if I was synthetically dividing negative 2 through here and I got those results down here, then I could conclude negative 2. There's no reason to search to the left of negative 2. And again, this used to be a big deal when we'd have big lists to search through, but we don't really have to search through those lists now in the age of your calculator. If there was ever a section that should be titled or subtitled, "Give your calculator a hug," this is it. Okay, this all builds to culminate right here. And right here is where the book is probably intending you to find the possible rationals, eliminate some with the upper bound, lower bound, eliminate some with the Descartes rule. And I'm just going to say, we're going to graph this. So let's go back into y equals. We're going to graph this function. And I'm going to clear this. And I'm going to go 4x to the fourth. Whoops, that's not a 4. That's a 4. Minus 11x to the third. Minus 22x squared. Plus 8x. Now, to find all the zeros, I do know that 0 is a 0. You might not see that right away, but if I put 0 in for x, since there's no constant term here, it's going to be a 0. But I'm going to go zoom standard here and hope it's going to give me some nice, easy to find zeros here. Say x. Okay, so I've got 0 is a 0. I know that. If I go trace and I put in 0, I've got a 0. I've got another 0 close to that. Now, hopefully you can see this. That 0 close to 0 could be a factor of 8 on 4. That might be 1/4, so I'm going to try 0.25. It is not 0.25. Maybe it's 0.5. It's not 0.5. I don't think that one's going to be rational. I'm going to go over here. It looks like 1, 2, 3, 4 might be, though. 4 is a 0. How about this one over here? I need something between negative 1 and 2 with a factor of 8 on a factor of 4. I don't think I can get something like 3/2 there. So here's the ones I've got so far. I'm pretty confident. Well, in fact, I know my zeros include 0 and 4. So if I take this function, first I'm going to just factor out the x. I'm going to get a 4x cubed minus 11x squared minus 22x plus 8. I've already accounted for the 4, so I'm going to take this function, synthetically divide it. I've in effect already divided it by the 0 to get this x term, x minus 0 out here. I'm going to divide it by 4. I expect that to work out evenly. Graphing calculator told me so. 4 and 16 and 5 and 20 and negative 2 and negative 8, 0. So right now I've got this factored into x times x minus 4, my box 4, times 4x squared plus 5x minus 2. and I'd like to know where that equals 0. And they're not going to be rational zeros because -8, there are not factors of -8 that add up to 5. So how do we solve this thing if we can't factor? If only there was some special formula for solving quadratic equations. X equals the opposite of b plus or minus square root of b squared minus 4. Wow, I can't tell you how many times great math students miss this. I've got -4 times a times c, but that's a minus times a positive times a minus. That's plus 4 times 4, 16 times 2, 32, all over 2a, 8. That is x equals -5 plus or minus root 57 all over 8. And my other zeros are 0 and 4. And this doesn't break down. Okay? Pretty slick. Now, you can save yourself some work if you're alert. Take a look. As soon as I set this equal to 0, I can reduce this by 3. So that gives me 2x to the 4th plus 11x cubed minus 23x plus 10. We'll have the same zeros as that. Okay, so let's go through this one more time here. Again, let's get a little of the light into there. Okay, y equals, and clear this guy out, 6x to the 4th plus 11x squared, nope, cubed minus 23x, just plain old x, and a plus 10. Did I get that right? No, it's 2x to the 4th because I reduced it. It's 2x to the 4th plus 11x cubed minus 23x plus 10. And of course, to graph it, you didn't have to reduce it. So I'm just going to zoom standard that. See if I can find some nice rational zeros along the way that would be factors of 10 on 2. Looks like maybe 0.5. Let's go. In fact, it looks like 1. 1 is, I'm just going to jot them down up here. My zeros include 1. How about 0.5? 0.5 is a 0. 1/2. How about -2? -2 is a 0. Looked like it might be. And 1, 2, 3, 4, 5. How about -5? Holy cow, we got them all. Not going to have to work too hard for this because there can't be more than 4 of the zeros. So my factors, well, we've got all the zeros. If I was going to factor this, I'm going to go ahead and do it. I'll show you something that happens here. I've got an x minus 1 times an x minus 1/2 times an x plus 2 times an x plus 5. However, I factored a 3 out of this to begin with, so there's a 3 here that could go back into there. Okay, so anyway, there's our zeros. There's your problem set. It's a lot of problems. We're going to put a lot of time into this. Hopefully by the time you're watching this video, you're well on your way to being through with it. Otherwise, you've let it build up on you, and you probably either had long-term absences or you're probably taking some zeros on quizzes because on part of your quiz grade because you do not have your assignments complete at this time. So anyway, hopefully that is helpful, and make certain that you are comfortable with everything in this section because it is all quizzable in the shortcoming. Thanks for watching, and stay tuned.